Let's break down this difficult but beautiful movement. Blanket statement: the muscle power to do this is just the required muscle power. You gotta be strong enough, no other way around it. But it is done in a specific way for a reason, to make it easier. Not easy, but easier. The arm holding the rope is a major fixed point. It will more or less stay in the same place, and the body will pivot around it. There is support of the body weight through the bones and the tension in the ligaments of the wrist and elbow joints. But there is also muscular contraction of all the arm to distribute that weight. This requires a lot of effort, but again, that makes the arm stable. So now that the arm is secured, the legs flex or come into a V or a pike. This allows the head to come down, the arm to come down, and the trunk to be positioned on this downward slope, pivoting through the shoulder joint. Then, once we've established this position, the upper body will counterbalance when the legs extend. Holding this straight body position is fairly obvious if you know some basic muscles. Erectors along the back, glutes and hamstrings for the femur, and for the pointy toes, the calf muscles. And just enough abs to reinforce the pelvis and lumbars. Notice that the non-rope holding side has been pulled up. This is done using some incredible muscular power. So to get there, we need to use any muscle that can pull in the transverse plane, or you could say cross body, from arm to spine, to yank that side up. That would be the rhomboids, the traps, middle and lower parts, and the latissimus dorsi, aka the lats. And the lats are an interesting one because they also help to generate or maintain the internal arm rotation. When we finally get there, the pectoral muscles will do, I believe, a very interesting thing. Through reaching this position, the pec muscles are technically lengthening, and so you wouldn't necessarily think they are contracting or holding anything. But as we reach max length, muscles tend to contract at least a little to support, resist strain, and/or the associated joint's dislocation. And now that the ribcage is pointed down on this holding arm side, it will be pressing down into the pec muscles, meaning they are supporting the ribcage. We could say a similar thing about the serratus anterior muscle. As well, because they're superiorly oriented, the upper fibers of the pecs and the upper fibers of the traps will resist downward slide of the body. One last thing. At the end range here, the body is actually resting on the arm. Somewhat. We established very first thing that the arm is acting as a strong fixed point to pivot around. But now at the end of the motion, the body is actually leaning onto it and has a small amount of decreased effort because of it. Getting there requires a lot of muscular force. Technically staying there does too, but just not as much.